So that is the case. So another reason why I do it, talking about making videos, but also for absences and the expectation. Okay, unfreeze and nothing changed. All right, and I will keep my picture up here because I kind of like that sometimes I can hit the screen and you see a double thing going on here. All right, so we should understand that X intercepts are where the graph crosses the X axis. I mean, I don't know how we could confuse that, but here is what I demand. All right, and then this actually tells you something mathematically. The X intercept is a coordinate, and you must write it as a coordinate and understand that the relationship for all X intercepts is you have 0 for Y, 0 for the Y coordinate. Remember I said that because I'm going to ask specific questions when it comes your turn. And I'm sorry, I already made a mistake right off the bat. Of course it's -1, comma 0. My bad, dogs. Rough. And then the other one is 3, comma 0. Okay? So we're all good there. And then do harp on and understand 3, comma 0. And then for a Y-intercept, I'm not changing colors. That is right here. That is 0 for an X coordinate and -3 for a Y coordinate. Yes, I'm going to say it. Grade school, this is what you learned on how to draw coordinates. You do X first and then Y. For the Y-intercept, I go 0 right and left and 3 down. That's why it's 0, comma, -3. Will not accept not having a coordinate form. I know I did a double negative there. So it must be in coordinate form. Let's write that, say that the right way. And then the vertex, I did tell you what it was. Hopefully you heard me here, that this is 1 for X, -4 for Y. All right, and I want to make a connection here because today we're going to be talking about another form. Let's just call it. Okay, we're going to talk about intercept form, which is actually X intercept form. Look at the relationship between the X intercepts and the vertex. I don't know where I'm going. I want to stick by the graph. Look at these 2 points, and then look at where the X coordinate is of the vertex between those 2 points. Because of symmetry, the X coordinate of the vertex is exactly in between the 2 X intercepts. Am I wrong or am I right? I'm right. Of course I am. All right. So fumble. I don't know what that was. Okay. So 1 is directly in between -1 and 3. Don't you agree that this is equal to 1? Just say yes after I'm done. What's -1 plus 3? 2. What's 2 divided by 2? Cover your nose and your mask. What's going on over there? All right. And then 2 divided by 2 is 1. Got it? So do understand it. This is called an average right here of the X-intercepts. And that's going to be a formula we're going to use later. Of course, the axis of symmetry is X equals 1. And I forgot all this black and stuff over here. I wanted to show you something about parabolas and tell you a little story. But let's finish this off. Then we'll go to parabolas in the real world. But we'll finish that off here shortly. The domain. Now, remember, you're going to be asked this. The calculator is going to pick you. So remember what I said about these. The domain is what can I plug in for X? You can plug anything for X when you're just squaring. There is no limitations. I wish I could tell you when there are limitations for a domain. We're going to wait on that. I don't know if I did yesterday. But just for parabolas, it's always going to be all real numbers for domain. But for range, you're limited. There is no graph down here. So these y's don't exist as a y coordinate for this particular picture. It starts here, and then these y's start repeating here, but these are all covered. You don't understand why students have a hard time with range and understanding what it is. We're doing it in CAT right now. Literally today, we're going to talk about how to find range from a function. More than just squares, though. That's with my seniors. So how do I do it? And you got to order this the right way. Last hour student made the mistake. I know I always point to my wall like I have a number line here, but I don't. But pretend I do, and zero's in the middle. What kind of numbers are over there, everybody? 3, 2, 1, go. Negative. What kind of numbers are over there, everyone? Positive. So when we answer questions, we must answer the way we read, right? We read, and we read left to right. So what is the range? It is -4 to infinity is what's covered on this graph. I mean, I don't know how else I can explain this. Here are the y values that are covered. These are all the y's that are covered. Don't get why students have such a hard time with range. There is no reason for it. Range means y. What y-axis values exist from the picture. And the picture should be enough in order to be able to do that. I didn't write something. And I did that on purpose. I wanted to make a big point. That is a bracket. That means including -4, right? -4 is specifically the vertex's y-coordinate. And then that leads to the next thing, minimum or maximum. Okay, this is actually a minimum because this is the absolute lowest part of this graph. As a matter of fact, this should be called an absolute minimum. But we'll wait till fourth quarter, if we had quarters here at Lockport, for the difference between absolute and relative minimum and maximum. But we'll just call it a minimum. And this is how you word it. The word minimum, just like intervals of increase and decrease, intervals of increase and decrease are describing what the y's are doing. So the minimum is the y-coordinate of the vertex. And then the way you word this, it's a minimum of -4 when x equals 1. I forgot to say this. Input, say it. Input, say it. So when I input 1, I get my minimum -4. And that's why it's worded that way. The whole input-output idea. And then intervals of increase and decrease, we did this yesterday. This is increasing when I read left to right. That's describing the y's. You need to name the inputs. This is already talking about the outputs are increasing when the inputs are 1 to infinity. Now, I'm going to explain this further why this is always a parenthesis. By that tangent line idea that I showed you yesterday when you guys asked me a question. I'm going to use this again. See that line right there? That's a tangent line right there at the vertex. This is the only special line that skips off that point and only hits the graph once. If I turn this in any way, shape, or form, you're hitting 2 points. What's the slope of that tangent line? 0. That means at 1, it's neither instantaneously increasing or decreasing. It's constant. So that's why we don't include 1. You never include the point where there's a change of direction. All right? And that's the idea behind that. That's the philosophy of why you never use a bracket for intervals of increase and decrease. And then -infinity to 1. Love throwing out that tangent line idea. Calculus kind of idea, but you can really talk about it now without doing calculus. Okay, and then I forgot to do this. Hey, anyone ever go to Cedar Point in Ohio? Raise your hand if you want, but not one person? Come on, raise your hand high. Cedar Point, Ohio. Are you raising your hand or not? I don't know. You're like this. Have you been to Cedar Point or not? You have no idea? Okay. It's a roller coaster park. You're the only one? Do you do the roller coaster where it shoots 120 miles an hour and then goes up that loop, spins, and then comes down? You didn't do that one? Oh, did you go this year, like recent? Okay, because this year, did you hear it closed because someone got hit with a piece of metal? Like a screw fell off or something? Ooh, well, I was lucky enough to go on that. So, the reason I'm bringing that up, it kind of looks like this, all right? But that's not the same one. I'm not sure where I got that from. But the reason I'm showing you this is, we're talking about parabolas, and students are like, this is so stupid. Why, parabola? Why do people care about the graphing and all that other stuff? It's because parabolas are all over the world. As a matter of fact, we went with Mr. Stronowski's family. We're really close friends. We've been working together for years. And our kids are the same age. His son's a senior, and he's going to go to be an engineer, but he really wants to design roller coasters. That's his dream. Right? And I just thought that would be cool, and there's so much math involved in that engineering. Of course, McDonald's, right? 2 parabolas. Anyway, I thought I'd share that. And then these 2 things. Anyone know where that's from? Anyone know where this is from? Raise your hand if you know. That's the Roman aqueduct. So, did you know that? You say what? Oh, France. I think, you know what? It's Rome, but Rome covered so many things. I'm not really exactly sure if it's in Italy or not. But I know the Romans built this, and this is like ancient. and it still stands today. This is the aqueduct system. This is part of why Rome was so successful. Clean water. In ancient times, that was not really, people that were smart enough to get clean water, that was a big deal. The whole reason why we had the plague in the 1500s is literally sewage was rolling through the streets. That's where the sewage would come. It was just a nasty, dirty time, and blah blah blah. But look at that. This is parabolic parabolas in architecture. Super strong structurally, and that's why that still stands to this day. And then, how many people have seen a dish before? Anyone? Well, I used to have a dish, but then I moved on, but we used to have a Dish Network, and this is called a paraboloid, a three-dimensional parabola. Oh, I should show you a thing about a Hubble Telescope. Anyone ever hear of Hubble Telescope? It was a national disaster when that first went up in the space. The paraboloid was off. It was a parabolic mirror, and it was off by micromillimeters, but it was off just enough where the collection of the data to make a picture was fuzzy, and they had to make a correction through another shuttle launch and make the correction. It's a fascinating thing. But this is what happens with a paraboloid. Hopefully I have my so what happens is you get signals that do hit that directly from space, but then the paraboloid actually is perfectly ground so that it bounces and then hits that focal position right there all the way around. And this is the only reason why you get a sharp picture. If this paraboloid was not to the right dimensions, then it would bounce off and miss that receptor. All right, so that's why you get such a clear picture from a dish. And many other things use dishes, not just pictures. So that's interesting. That's just a three-dimensional parabolic situation there. All right, so it's all over in the world. You're just at the beginning stages of seeing this stuff. Anyone seen the Karate Kid? I always use the reference wax on, wax off. Why am I doing this? You'll find out. All right, and that's the idea behind that. Go ahead and write this down again. And I'm just going to scratch this off because today you can't be robots. You got to start recognizing. I incorporate the last 2 days of notes in your homework. And actually, they're in our notes. And when your number gets called, somebody in this row has been called already. You'll find out who. You have to tell me what form do I have, and then what do I do. So I'll zoom up to this and maybe just show this a little bit bigger here. A review. Remember vertex form. That's what you had yesterday. A times x minus h squared plus k. I'll give you a chance to write this down notes-wise. The graph of this is the parabola y equals ax squared translated. Now, the minus h, we know on the inside, we better, from yesterday's homework, that's either a right or a left shift. And we want to be thinking opposite. And I'm going to write that down here in that part that I scratched off. So if this said x minus 2, you better darn well have said 2 comma. 2 is the vertex. X minus 2, or if I plug in 2, 2 minus 2 is 0. It's the 0 of that parenthesis. That's what ends up being the x coordinate of the vertex. And then the k on the outside is an up-down shift. And that's what we want to think same. And the reason we think that is, or say that, is because if this said plus 4 on the outside, then it does go 4 up, what we would think would happen. If it says minus 2 on the outside, it is 2 down. And then therefore the x coordinate, or the y coordinates vertex is negative 2. You should already be really good with that after yesterday's homework. That's the point of it. But really what we got, I was kind of looking ahead, 3 lessons from now, maybe Tuesday. I think it's Tuesday, maybe Wednesday. We put all these forms together. I have another one Monday or Tuesday. Sorry, I'm getting my days all mixed up. I forgot we don't have school Monday. Yay! All right, awesome. So the vertex is h comma k. And the axis of symmetry is x equals whatever the coordinate of the x for the vertex is. If I said that right, I kind of messed up my words there. All right, for the horizontal translation, it's H, but I'm just going to think opposite again. You don't have to rewrite this. And then vertical translation, think same. And that's all I want you to write for that. So just remind yourself, because someone's going to get called and that may very well be this from yesterday. Can't be a robot and think that everything that you look at is the same as what we're doing in this one day. Hurry up. Yep. You didn't write that up there? What are we doing over there? It's go get faster, faster. That's a U, up, down. Up, down. What time we got here? 30? Is that what it says? 30? 30? I know, what does that say? 2 or 8? 2? I should have worn my glasses. I told you, I leave my glasses in the car. Actually can't read the screen with my glasses on. Anyone, what do you have to far, what is that, far side or, I can't see far away, so is that nearsighted? Isn't it like the opposite? But then if I had my glasses on, I couldn't even read the screen. What are you? Is it nearsighted or farsighted? Nearsighted, so you, same as me, right? Is that what I said? Okay. That's why I don't really want them on. Then I'd lose them here, I'd leave them here, and I wouldn't have them in the car. More important that I have them in the car. All right, now this is where you identify differences. Now, obviously, you see P's and Q's. Okay, this form has P's and Q's. Now, there's going to be numbers. You have to understand that you have how many sets of parentheses? It's very simple. How many sets do you see? 2. I don't know how you can misidentify how this one's different than the other one. So here's our intercept form, and they decided, and I think many other books decided to just use the letters P and Q to represent, sure, the X intercepts. Now I'm going to throw this at you. Hint, hint, people in the last row, whoever gets picked. The first example is this form. That's going to be your first question. And I'll prove why, when it's in this form, the X intercepts are P, 0, and Q, 0. Again, you could think opposite. But you'll see why this is so easy. Again, it's about making the parentheses 0. You should be able to be a good algebra student. If I took X and replaced it with P, P minus P is 0. That's the point. If I replace X with this Q here, Q minus Q is 0. So yeah, there's a big deal to that. Very similar to, the other form with the H, of course. All right, and then the axis of symmetry. I just told you this. So I'm going to let you write this, but just give me a second. I just told you this with this one right here. Look, I want to make sure you can see me in that screen over there. The axis of symmetry is exactly in between these two X-intercepts. Exactly. And I even put that math down here. -1 plus 3 divided by 2 equals the vertex's x-coordinate. Hence equals the axis of symmetry value, x equals. So, just to reiterate and state that one more time, the axis of symmetry is exactly between P, 0 and Q, 0. It has to be. There is symmetry with parabolas. So the equation for the axis of symmetry when you're in this form is find the sum of the two x-coordinates and divide by 2. And then I'm going to take it a step further and then give you some function notation. Vertex. By the way, when I say input, you say, so the vertex's x value, of course, is the same. Whatever the average of the two x-coordinates of the intercepts are. Okay? That's an x value. How do I find a y? When I say input, you say, you input this into the function and get the output. That is function notation for output. F of whatever that is means I go to the function and plug that in and get the output. So students always get all jacked up when they see like F of notation and what that means. That's what it means. Okay, and you don't really need to have that as a complicated thing. You should understand that as we move forward. Okay, here we go. Boom shakalaka. It was 25. So that was Natalia. I didn't say your last name, right? So you're okay. That's you're 25, right? 27, Gabriella, right? Your last, so 25. Okay, so remember what I said? What form do you recognize here? We'll zoom in on this so people can see that. Is that intercept form or is that our original from yesterday, vertex form? Intercept, you see two parentheses. I don't understand the student that cannot recognize differences. All right, now can you tell me, Natalia, I'm putting you on the spot. What are those X intercepts? And now I'm going to explain it. So what's that first one? What's the X intercept for that? Okay, now what happens when I say -1? Is -1 minus 1 0? Yes or no? No, so what is it actually? It's 1 comma 0. And then I'm going to explain it. And then do the other one. Okay, and then I'm going to explain both of them, and we should be able to understand this as a simplistic math concept. Thank you, OneNote. Always screwing up on me. Love that program. Listen! When I plug in 1, answer the question. What's 1 minus 1, everybody? 0 times who cares times who cares. What's the answer? 0. 0 times anything is 0. Fine. I'll plug in 1 over here. This is 1 minus 5, which is -4. 0 times -4 times 2 is still 0. Input, say it. I just inputted this, and I got an output as that. Same thing with 5. 5 minus 5 is 0. 5 minus 1 is 4. Who cares? 0 times 4 times 2 is 0. Input, output. Those have to be the x-intercepts because when I graph those, they are on the x-axis. Who's moving around? What's going on? You're very fidgety. All right. I have a hard time paying attention when you're moving around and shaking and okay, 1, 2, 3, 4, 5. Okay, so there, when I graph those, that's what I get. All right, fine. I have a chart of values, just humor me. Put 1 comma 0 on the chart of value because we did evaluate. There we go. OneNote, thank you every day. All right, good. So we got that, and hopefully we make that correction and actually have understanding, not just hey, what's the formula, kind of thing. Ashley, how do I find a y-intercept? What do I have to do? There you go. So here's the evaluation of a y-intercept. And then what do you get, Ashley? Oh, this is -1 and -5. What's a negative times a negative? And by the way, which way should our parabola go, up or down? Up. So if you did, I'm going to do a correction here. If you said 0, -10, could that be possible if this goes up? No. So you'd say, wait a minute, something's wrong. Try to put the two together and then say, all right, I got to make a correction here. And it is 10. So guess what I'm going to do here? Sorry, I should have shoved this right here. 0, comma 10. If your teacher asked for 5 coordinates at least, and one of them is the y-intercept, 0, comma 10, I really hope we can evaluate. That should not be something that we stumble on. Then we should know. Okay, wait. I'm going to wait. I'm going to find the vertex next. Okay, so how do I find the vertex, or what are the components that I need, or a component? Oh, I almost mishit there. Oh, no. I'm sorry, Natalia, but the calculator rules. All right, how do I find the vertex, or what is the x-coordinate of the vertex? You don't have to have a formula for this. Okay, what's the x-coordinate of the vertex? It is 3. When you graph, you could quite simply see that it's 3. Or off to the side, what do we have? 1 and 5. 1 plus 5 divided by 2 if you wanted to do the math, the average of the two x-intercepts. Or just count. The x-intercepts are 4 away, so the vertex should be 2 away from each one of those. Input, say it. How do I find the y-coordinate? What do I have to do? Plug in 3, 4, which variable? Oh, What coordinate is that? Which coordinate's listed first? X. Okay, so you plug in 3 for X. Do your evaluation for this and tell me what you get. So zoom in on that now that we're on Vertex. By the way, everyone, what should I get, a positive or a negative, the way the picture's shaping out here? Positive or negative? Should be a negative. Don't say what the answer is. What'd you get? Ooh, 3 minus 1 is 2. 3 minus 5 is negative 2. That's negative 4, but times another 2. It's negative 8. So we got to be good with our evaluations. I hope that's not what will be stumbling us on this. All right, now here's what I was going to say about my chart. And I left a really, okay, on the chart, I'll put 3, negative 8. I don't know if I'll require a chart if I have all this stuff, but I like to have 5 points. And the last one I'm not going to evaluate because watch what I'm going to do. I'm going to draw a little axis of symmetry. I don't know if I have axis of symmetry on here. I must have cut that off too. But axis of symmetry is x equals 3. And then watch. 1, 2, 3. Sha-na-na-na-na-na. 1, 2, 3. Da-na-na-na-na-na. That's my reflection sound. So actually what this is saying is that coordinate is, if I wanted to put it on here, 6, 10 as well. Sorry for my bad writing there. If a teacher forced you to have 5 coordinates on the chart, everybody, all right, and then I could just do reflection over the axis of symmetry to get this other one and not actually evaluate. If you wanted to evaluate to check it, then go ahead. All right, so I know this is brand new, but hopefully the things that I'm showing you are connecting here. 26, nice, Patricia, we're sticking in that row there. What's the domain? Good. And then what's the range? Let's see if you got this range down. Last hour was a little shaky with it too, but that's why I'm putting you on the spot here. I'll have come over here if you're not ready for the answer. You got all these white, but then there's a hole here. This graph is, nothing exists down here. So what is the range? What's the first y coordinate that you see that exists? What is that y coordinate right there? No, it's no, it's not. It's the vertex's y coordinate. So what is that? Negative 8. Okay, and then what are the y's after that are covered? Is it smaller than negative 8 that are covered, or bigger than negative 8? Bigger. How do I write that in? Thinking of a number line, reading left to right. And then what do I put on negative 8? You got it. And infinity always has a parenthesis. I forgot to say this. CAT students ask me this. Because the idea is you can't get to the biggest number. You're approaching the biggest number. The idea that no matter what number you give me, I could always add 1 and it'd be bigger than that. Right, and then just for purposes of this, what is this? A mix, a minimum or a maximum? I'm putting 2 words together there. It's a minimum because there's no lower point than this of negative 8 when x equals 3. All right, and then interval of increase and decrease. Let's make sure we have this one. Ooh, we're calling you out here. This was from yesterday's homework anyway. Student number 5. Good, Madison back there. So what's the interval of increase? Here, I'll give you, obviously where it increases. I don't think that should be the problem. But what is the interval that we name? And actually, this tells me about where we're at, too. If I'm getting answers right away, we got it. If it's taking a while, then we got to work on it, all right? And I think that's where we're at. We got to work on it. Both periods, we're taking the time to get this answered. So what's the interval of increase? Okay, so it's the x's, and obviously this is what I plug in. So I need that interval right there. What is this x coordinate right here, the x coordinate of the vertex? 3. Okay, now give me the interval of decrease. And by the way, you never use brackets. Sorry, I don't have decrease. I'll put decrease right here. Now be careful. You got to go in order. Watch my hand. You got to name these x's. All the way over there in order to this one right here. What is that in order? Do it one more time. All the way over there to this x coordinate right here. What's all the way over there? Negative infinity to what? 3. Now I hope you got it locked in as I put the pressure on you. First hour had the same problem. Obviously we don't have intervals of increase and decrease down right now, right? And that's what we got to do. First hour, the first person that answered super quick named the y's. They said the interval of increase was -8 to infinity because they're looking at the y's. They go, never the y's. The word increase describes already the y's. Output, what's the input? You're naming the inputs that make the increasing output. All right, and that's another why. That's why I always say input output. We'll break this one apart again. Student number 1, nice, Ashley. Calculator loves you. Okay, real quick, what is that form that you see right there? I'll zoom in. That's vertex. And then I'm going to tell you something. We started something on this, but then I realized we have to wait to chapter 4 in order to do something. But what is the vertex? Then we're going to skip to that part. And then again, the idea of input-output. If I throw in 3, it's the 0 of this. That's also why it's opposite. 3 minus 3 is 0. 0 squared is 0. Times a half is still 0. Plus 1. Input-output. It's proven to be 3, 1. At least as a coordinate. And then that goes right in the middle of your situation there. Right in the middle of your chart, I mean. Here's the problem. Ashley, I am going to ask you this. What's 0 for X intercepts? Look at X intercepts here. This is why I gave you this in the beginning. Look at the X intercepts. What do they have in common? 0 for what? The Y. So to find an X intercept, you would plug in, say what we just said. 0 for Y. Here's the problem with that. You're not ready for this yet. This is chapter 4 solving this. I bet you could handle it if I showed you. But this is what you'd have to evaluate for this. So what I'm going to say, and I was about to first hour start like talking about how to solve for that, which isn't really a big deal. I will tell you if you're curious. You subtract 1, multiply by 2. What's the opposite operation of squaring? Square root both sides. The problem is you have to put a plus minus in front of your answer after that. There's 2 answers. And we're going to cover that in chapter 4. So we're going to wait. So I wouldn't ask you how to find necessarily the X-intercepts yet on vertex form. Be very specific what I just said there. Vertex form, finding the X-intercepts, we got to work on that. We're a little out of order on that. So we wanted to show intercept form. We did want to show intercept form, but this book waits till chapter 4 to talk about intercept form. We wanted it now. We wanted it in our graphing chapter. I'll get someone else, unless the calculator loves you again, or anyone else. 25 has been picked by. Okay, good. 18. We got to mix her up here. Aiden, where you at, Aiden? Oh, nice. The guy that ripped that homework off the pile. He was so mad. Hey, then how do you find it? Cover your nose. Come on, man, with your new mask. All right. How do you find a Y-intercept then? You plug in what for X? You got it. What do you plug in for X? Oh. So for an X-intercept, we plug in 0 for Y. For a Y-intercept, we plug in 0 for X. There you go. And this one can be evaluated. So I want you to evaluate this. Oh, no. PEMDAS. What's 0 minus 3, Aiden? But what's -3 squared? 9. Correct. What's 9 times a half? Just make it an improper fraction. Is that the right word? Bigger numerator. What's 9 times a half? Just, or 9/2. Good. I like that. What's, okay, what's 4.5 plus 1? I'll keep that. 5.5. So y-intercept is 0, 5.5. Guess what? What else has 5.5 as a y coordinate? Anyone know? Yes. 6. So this is what I mean about if you were forced to do a chart of values, use symmetry. Okay, and then I could start graphing this. 3, 1, 1, 2, 3, 1. Come on. One note, I love you. All right, 0, 5.5, 1, 2, 3, 4, 5.5. And then I'll show you how you can cheat and get another set of coordinates. 1, 2, 3, 1, 2, 3, 4, 5.5. Remember what I told you about 1/2? It's the slope for the very next set of points after the vertex. So I guarantee you, rise 1, run 2, you would get 1, 2. Plug in 1, you would get 2 for the output value. Rise 1 and run 2, I guarantee you would get 1, 2, and 1, 2, 3, 4, 5, 2. Guarantee it. So you really don't even have to evaluate. You can use symmetry, and then you can use the next set of points, how, that number, that A in front. And then we could go like that. Woo! And then this one is shrunk by a factor of 1/2. You can see that it's pulled towards a little bit wider. All right, and just because all day long, this hasn't been like super fast. I don't know if we have domain and range down, and that's fine. That's why I identify these things. Jessica, what's the domain of this? What's the range? What do I have on 1? You are correct, because 1 is the first, if you want to call it that. So what? Then let's finish that off. What's min, or is it a minimum or a maximum? What is the minimum? When x equals, yeah, that's how you word all that. Awesome. All right, let's get someone else. Well done. And then entry 7. Nice. Let's see where we're at, Sophia, on intervals of increase and decrease. Okay, so 3 to infinity, parentheses or brackets? Always, and then the interval of decrease. Awesome. Okay, and then we're getting down to it. So I'm going to show you the next one, but don't even write it. I'm going to verbalize some things though. And I think I should have access to symmetry, which is x equals 3. Look for that in your homework. Okay, quick group response. What form is this? Intercept or vertex? 3, 2, 1, go. Intercept. So we're going to find the x intercepts first. Which way does this go? Up or down? 3, 2, 1, go. Down. All right, and know those things before you actually get into this question. You would actually have a maximum then. This is going to go down in some way, shape, or form. So that vertex is actually called a maximum. But we don't have time. And then I was a little probably overzealous for the notes. I'm telling you for sure that these 4 questions that I have here are all really exactly the same. See, this is just a picture with coordinates. This is a word problem that tells you about the coordinates. So don't write them down, but tell me for this one, which form would I use for example form? Example 4, intercept or vertex form? 3, 2, 1, go. It says the X intercept, so we're going to use intercept form. What about this one? Example 5, vertex or intercept? 3, 2, 1. It says vertex. You use vertex. What's given here? Don't put your stuff away. How dare you? We have 5 minutes. So I'm going to do one more. What would I use for this one? Intercept or vertex form? 3, 2, 1. That's the vertex. We are actually going to do this one. Okay, so that's what I mean about being robots. You see what you have first, and then you choose the appropriate formula. What I'm saying on this one is you use what I used yesterday. I would write y equals x minus h squared plus k. I'd use the hk one for this one. This one, obviously, I'd use the intercept form. So therefore, I would use this one. And then I'll leave you alone on this. We'll do a group response. This is so fun. Okay, by the way, this is -3, 0. This is 1, 2, 3, 4, 0. And then this is arbitrarily 0, -6. Okay, now very specific. Where would I plug in 0? Would it be y, x, p, or q? 3, 2, 1, go. X. You are correct. This is an arbitrary x value. It doesn't have to be the y-intercept. It could have been any of these other points other than the intercepts. So therefore, where would I plug this at? 3, 2, 1, go. Y. And then this you have a choice, but where do you think you'd plug in -3? 3, 2, 1, go. It's either P or Q, right? But we'll probably pick P, and then therefore if I pick P for that, I would pick Q for this one. And then that's how this one works. You plug in -6 for Y. You're trying to find A. You'd plug in 0 for X in both of these positions. Yes. And then you plug in P maybe for -3 minus negative. And Q was 4 minus 4. And then this is very evaluatable. All right, so I get -6. By the way, what kind of A value should I get, positive or negative? Positive, because this is going up. Sometimes you're robotic, you get a -A because you made a mistake and you just put the -A in there. There is no way that could be a -A. It's impossible. It's going up. All right, and then this becomes -6 equals -12A. A equals a half. But that's not the final answer. The final answer is taking that y back, because you have an infinite amount of x comma y's. So now the equation that makes this graph, you need the x and the y back. 1/2, and then, this graph always has 3 as an x-intercept, -3, I'm sorry, and 4 as an x-intercept. So you bring the -3, and the 4 back. That's the equation of that parabola, okay? So it's very similar, except you got to know which form to use, and you toggle between those two. Let's see if I forgot anything else. Nope, that's good. All right, good deal. Yes, you got to do all. Who asked that earlier? Do we have to do all of this, or maybe that was last hour?